We're going to wrap up our unit on congruent triangles today as we take a look at what's known as CPCTC. Right now it might seem like a bunch of alphabet soup, similar to the other shortcuts we've been talking about with SSS, SAS, ASA, HL. But we'll get some more significance to what CPCTC stands for as we continue working with congruent triangles, and we're going to work with proving that corresponding parts of congruent triangles are congruent. So as we take a look at congruent triangles, congruent means that they have the same shape and size. So if these two triangles are congruent, the purple one and the green one, we can see that all angles are congruent and all sides are congruent. The green one is just flipped around, but they're both the same shape and size. So with that in mind, we know that congruent parts, congruent parts of congruent triangles are going to be congruent. So we have this abbreviation known as CPCTC. So if I know triangles are congruent, I know any of their corresponding parts will be congruent as well. So corresponding parts of congruent triangles are congruent. And we can abbreviate that with our CPCTC. So we don't have to say that whole phrase anytime we want to show that corresponding parts of those congruent triangles are congruent. So let's take a look at where we can use this. We've got a proof where we know M is congruent to Q and MQ bisects PN. We want to prove that angle P and angle N are congruent. We can see that those two angles are part of two triangles. So the process is, if we can prove those triangles congruent, we can prove the corresponding parts congruent. Let's start off with our statements and reasons and get a proof going. First thing, angle M is congruent to angle Q. That's given. We also know that MQ bisects segment PN. That is also given. I know that if MQ bisects PN, I know PO will be congruent to NO. And that's just a definition of a bisector. I know that's what a bisector does. It splits the side into two equal parts. So right now I've got an angle, and I've got a side congruent. I need at least one more angle or side. So I see this angle here, angle POQ, and angle NOM are vertical angles. So I know angle POQ will be congruent to angle NOM because I know vertical angles are congruent. So now we have our combination, and we can say that the triangle POQ is congruent to triangle NOM. We just got to make sure that congruent statement is correct. I know that angle P matches with angle N, O matches with O, and Q matches with M. So I got to make sure I put that in the correct order. And I see that those are, we have a angle, angle, and side. So we'll say it's by angle, angle, side, congruence. So now that I've proven the triangles are congruent, I know any of the corresponding sides, whether it be PQ and NM, or whether it's angle P and angle N. And I just want to prove that angle P and angle N are congruent. So I can state that now. Angle P is congruent to angle N because corresponding parts of congruent triangles are congruent. Now take a look at the next example and feel free to try this one on your own. Pause the video and come back when you're ready to check it over. Okay, so hopefully you marked up your diagram as you got the information. EF congruent to EH, FG congruent to GH, and those are both given, either order, it doesn't matter. Then I can see that as there are two different triangles and EG is in both triangles, so I can say EG is congruent to EG by the reflexive property. Now I have three sides congruent, and when I have all three sides congruent, the triangles are congruent by side, side, side congruence. So make sure I match up corresponding angles, FGE, HGE. You can see the triangles are just reflected across line EG. And then since triangles are congruent, all corresponding angles are congruent. So angle F would be congruent to angle H, because corresponding parts of congruent triangles are congruent. Okay, in the next one, I'm going to show you what's known as a flow proof, or flow. It's kind of a flow chart that directs all the information down using arrows and boxes. The first thing we have is we have angle 1 congruent to angle 4. And I know those are congruent because that information is given. Okay, that's one angle that we're looking to find. The other one is angle 2 congruent to angle 3. And that's also given to me. That's another angle that we have. You might find that this might be a little bit easier to organize since you just throw the information out there and then just draw arrows to connect it all. So if I'm trying to find JK congruent to LM, I'm just going to mark that on my diagram, see what I'm trying to find. I see that those are part of two different triangles. Okay, and as I compare those two triangles, I'm going to need to prove those triangles congruent so I can prove corresponding parts congruent. Right now I have two angles. If I can find another side that can help me. And I see that both triangles contain this side, side LJ. So I'm going to say LJ is congruent to LJ because that's the reflexive property. They share the same side. That's another side that I found. So now that I have all three of those bits of information, because I have all three of those pieces, that helps me prove triangles congruent. Triangle LJK congruent to triangle JML, because I have angle, side, angle. The side is included between the two angles. So now that I've proven both triangles congruent, I can prove any corresponding parts congruent. And since JK and LM are corresponding parts of that triangle, I can now prove that JK is congruent to LM, because corresponding parts congruent triangles are congruent. So it's just another way that you can write proofs. You might find that two-column proofs are easier, or maybe you prefer flowchart proof. So just pick whichever format is easier for you to organize the information. And finally, just an example of how this is used kind of in the real world. If you're trying to measure across a river, you might want to take your tape measure out and measure it, but it might get wet or fall in the river. It might be a little difficult. So another way that this can be done is by staking out ropes and measuring across dry land. So if you take a look on there, let's say we want to measure from point N to P. Well, if you place a stake on point K on the near side of the river so that NK is perpendicular to NP, you've got a right angle there. M is the midpoint of NK. So this point is halfway between those, and you can measure those out. You're going to locate a point L so that NK is perpendicular to KL on the dry land side of the river. And we'll have points L, M, and P all collinear. So when you do that, you see you have two triangles formed. And how does that help us find the distance? Well, we know we have an angle congruent in both of them because we have two right angles. We have two sides congruent because we have the midpoint. And we also have vertical angles here. And so now by angle side angle congruence, a triangle PNM would be congruent to triangle LKM. And so by corresponding parts congruent triangles being congruent, we could measure LK, and it would be equal to, or it would be congruent to the side that we want to measure, to side NP, which is that distance across the river. So just by using your knowledge of triangles and congruent triangles, you wouldn't have to get yourself wet if you wanted to measure that distance across the water. So today we learned the final bit of our alphabet soup, CPCTC, and found out that when we have congruent triangles, all the corresponding parts are congruent, and that can help us to prove different angles or segments of triangles if we can first prove the triangle is congruent. You'll get some practice on different proofs like that in your assignment.